So the first vaccine was the Pfizer-BioNTech vaccine, and it had its day before the FDA on December the 10th. Now that is moving rapidly towards emergency use authorization. I think it will be shipped this coming week. Now the first people to receive this are going to be nursing home residents and healthcare professionals. So in our system, it's going to be those in the hospital, so ER, ICU, and on the medical floors. There are other vaccinations coming, other companies, and the next one is Moderna on December the 17th. On Thursday, Moderna will have its day before the FDA to convince it to give the emergency use authorization, and it most likely will get authorization also. As you heard, both of these vaccines are mRNA, and they both have had very good results. So the Moderna, just a little word about how quickly it came. The Moderna vaccination was devised on January the 13th. So it was January the 7th when China told the world that this was a coronavirus and it was a new novel virus. On January the 11th, they decoded the genetic code of the virus, and that was shared with the rest of the world. By January the 13th, Moderna, a small company in Massachusetts, was able to choose the sequence that they wanted from that virus that they wanted to attack with a vaccination. And they were going to use mRNA technology because they've had about 10 other trials that they have ongoing with other vaccines that are mRNA. So they've already been doing this. Now, they have not had any of these come to the market because usually it takes much more time. But because of this, they've been working on mRNA vaccines, and they were ready for it. So it only took them a couple days to choose the sequence of the virus that they wanted to attack, and then to put a lipoprotein around it to protect it when it's injected, and then to start the process of getting approval by the NIH. So they did some in-house testing of it, and it was just by February that they gave it to the National Institutes of Health to let them examine it and see if they could go on with phase 1 trials. And that's how it happened so quickly. You know, with other vaccines that you have to produce a virus, you have to grow the virus. It's a living organism, so you have to culture it. It takes a lot of time. Here they just space together nucleotides to form messenger RNA. So just a little word about how this vaccination works, and I'll show you that just now.
Let's talk about how a vaccine like this works. So we'll talk specifically about Moderna's 1273 mRNA vaccine. So this vaccine, when it's injected into the extracellular space, which I've drawn out here, and this right here is the cell surface in the cell with nucleus and a ribosome. So the messenger RNA is not all by itself. Moderna has placed this in its own blend of lipoproteins or lipids. Lipids are fatty molecules, and they're relatively inert. Just think of fat. It doesn't do much of anything. It doesn't interact with things, so that lipid layer helps protect mRNA from being broken down. If you just left mRNA by itself out here in the extracellular space, it would probably pretty quickly be broken down and never reach the cell and never be able to do what it's supposed to do as a vaccine. When it gets to the cell does accept this into it. So now it's inside the cell in the cytoplasm. Now note where it is. It's nowhere near our DNA. Our DNA is in our nucleus. The DNA is intact. It's a double-stranded helix of nucleotides that encodes all of our genetic information. In no way does the mRNA go in and affect our DNA in this particular vaccine. But it is translated. So this mRNA goes to a ribosome, this little structure here, an organelle that looks like RTD2. So it goes here, and this is just a string of nucleotides. Nucleotides encode for amino acids. Amino acids, when you chain them together, become proteins. So amino acids correspond to the nucleotides. So if there's three triplets, three nucleotides in a row, it encodes for a specific amino acid. So for every 3 nucleotides, 1 amino acid is chained on, and all these amino acids are chained on, and they produce a protein. In this case, I'm going to call it SP, or spike protein, which is what this particular messenger RNA encodes for. This SP is presented to the extracellular space, spike protein. And so on the surface of that cell, it presents it to the cellular world. and T cells come by. T cells will see this protein as not of its own self. So as a foreign particle, it will process it as such, and the immune system will be triggered. So the immune system is triggered. This T cell will present SP, the spike protein from the virus, to a B cell. B cells are important because they produce antibodies, commonly noted as such. So there you have, in a nutshell, the immune triggering. There's more to that. The B cell will become a plasma cell, and it produces lots of antibodies that are out in the body, in the extracellular space, in our veins and our arteries, and they're looking for virus to attach to. So B cells produce antibodies. Also, the T cell will go on to produce a T helper cell or a T memory cell. So some of these T cells have memory, and they know that spikes protein when it comes around, and those are also circulating around looking for that spike cell. So without getting an infection, you have introduced a piece of the virus to the body. The body has processed that with its immune system, and now the immune system is geared and ready. It can smell it, it can see it, it knows the spike protein, and it's ready to destroy it when it first enters the body. That's the way this vaccine works. It's RNA. It uses some of our own machinery, a ribosome, to produce a protein, which that protein triggers the immune process, producing B cells, antibodies, and T memory cells, which are circulating today to help us fight the virus tomorrow.
So you see a little bit about how a messenger RNA works. I want to give you a study that talks about how that immune process has durability over time. So on December the 3rd, the New England Journal of Medicine published a paper put out by Moderna and its makers and scientists that talked about the durability of the immune response to the M1273 mRNA. So in that, they took the phase 1 participants. Now, there were just about 30 or 40 participants in phase 1. Remember, that happened back in March and April. They started to give the 40 or so participants 2 shots. 1 shot day 0, and then 28 days later they gave the second dose. Now, they followed them, and they're going to follow those phase 1 participants for a full year to watch for any side effects and to watch for if they get sick and to watch what their antibody levels are when they draw their blood. So at 119 days from the first day of vaccination, they examined their blood for antibodies. They examined the blood to see if they were neutralizing antibodies or binding antibodies, so different kinds of antibodies, to see if they're effective, and thus if they're going to be protected from the infection from the virus. And so at day 119, all the participants had immune response that was durable. It was still going on. Now, the levels of antibodies had declined just slightly over time, which we would expect with any kind of immune response. The antibody levels slowly decline, but they were still sufficient to neutralize or to fight a virus. So that was great news. 4 months out from the first vaccination, the participants in the vaccine had active and sufficient doses of antibodies in their system. Now, another interesting thing, they were compared to a control cohort of people who were infected with COVID-19. So they took about 34 people who were infected with COVID-19, and they examined their blood for antibodies and binding and neutralizing antibodies. The levels of antibodies in those that had the natural infection were actually lower at day 34 than those of the vaccination at day 119. So it doesn't necessarily prove that the vaccination gives you better immunity, because there's other factors like we talked about, B cells, T cells. So we don't know exactly if it's going to be better, but that's very promising that the vaccination produced higher levels of measurable antibody than a natural infection did. Very good news. They also were able to evaluate the vaccination participants, and they did have levels of T cells. B cells they're going to examine as they go, but those studies are still ongoing. So good news about Moderna's vaccination and its durability over at least 4 months. So the second vaccine goes to the FDA this week. There will be more. Realize that not all of them are mRNA vaccines. Novavax is still in phase 1, phase 2 trials, but they have one that is a more typical manufactured antigen that does not use mRNA technology. AstraZeneca has a vaccine that's coming up. It's marketed more for a global distribution that's going to be more affordable, and that's great news too, so that more people can receive vaccination that need it. So I hope this helps. Be sure to ask me any questions you'd like. You can instant message me or reply down on the Facebook feed. Thanks.